Okay. A little more about graphs of power functions just to get a better feel for them. If when x is -2, y equals x to the p is -32, where p is a positive power, then what can we infer about the graph? I claim we can infer everything about the graph between -2 and 2, at least enough to make a good sketch. And I've done that here, but let's see how this works out. Okay, first of all, x being negative makes y negative. This means that the values of y for all negative values of x are going to be negative. Just looking here, well, we haven't really done it, but you should understand from what you know about the x squared and x cubed function, in addition to the reciprocal function, reciprocal square function, that when the power is even, then all values are positive. If the power is odd, then when the x values are negative, the y values are negative. And that just goes down to the rules for multiplying negative numbers. Okay, so we can conclude that all the y values are negative. We also know for any power function with positive p that x to the p is 0. That 0 to the p is 0. So when x is 0, we're going to be at the origin. We also know when x is 1, y is 1. And when x is -1, well, y is either positive or -1. So we know all these values. So knowing that y is -32 when x is -2, again tells us that the y values for all negative x values are negative. And there's only one other thing we need to realize, which is that, okay, if we compare the value of the function at 1/2 with the value at 2, we see they're reciprocals. And that's pretty obvious. 1/2 to any power, 1/2 to any power is 1 divided by 2 to that power. But here is 2 to that power. So in this case, the power is 2. 2 to the second power is 4. And 1/2 to the second power is going to be 1/2 to the second power. That's going to be 1/4. For the same reason, we've got x cubed to 1/2 and 2. The values of y at x equals 1/2 and 2 are going to be reciprocals, always. Well, this tells us that we can conclude that when x is -1/2, y has to be 1/32. Of course, I'll write that as -1/32. So now I've inferred all the values for negative x, and then the values for positive x, of course 1 is going to give you 1, are just going to be equal to the magnitude of all the values of the negative powers. Again, that's a pattern that you've observed if you've done what you've been asked to so far, and it's not a hard pattern to understand. Okay, so let's consider this one, okay? Now x is 1/4096 when y is 1/4096 when x is -1/2. So that means we got the point here where we have -1/2, and our y value is 1/4096. So let's just say here is 1/4096. Okay, well, when x equals -1, the value is either 1 or -1. Since this is positive, 1/4096 is clearly a positive number, then it has to be +1. So we have 1 here. Now, 1's going to be way up here. It's going to be 4096 of these. If I make 4096 marks separated by that much, I'm going to be through the roof. So I'm going to fudge a little bit and say, well, let's just put it here. It's going to be much higher than this. And then, of course, when x is -2, we're going to get the reciprocal of this, which is 4096. So we have this point, which is -1, 1. And then we have another point way up here, which is going to be -2, 4096. It's going to be way up there. So, coming down from way up there, we're gonna be coming down almost vertically. And we're gonna stay almost vertical until we get down very close to the origin. We're gonna have a graph that looks something like this. And then we could do the 1/2, the 1, and the 2. The graph is gonna just be the same shape. It's gonna go on up to 4096 by the time you get to 2. So, possible to reason all this out if you're given the value of x at -1/2 or at -2.